Well, how's it going, class? Today we're going to be looking at acids and bases. And so we've been talking about matter and what makes matter up. And now we're going to talk about some of those classifications that we can continue to put matter in. This week we're going to do a couple of labs as well that'll deal with that and using some indicators, which we'll talk about. So let's look at acids and bases. Acidity and basicity are two chemical properties that help scientists identify matter. Acidity is the state of being an acid. Basicity is the state of being basic. And so we'll talk about what each one of those things are. So let's look at acids first. An acid is any compound that contains hydrogen ions. So when acids are dissolved into a water, hydrogen ions are released into the solution. And so when you squeeze that lemon into the water at the restaurant, that acid is being released into the water and dissolving and releasing those hydrogen ions. So anything that has those hydrogen ions is going to be considered an acid. Acids share some common properties or characteristics across the board, no matter what they are. Acids have a sour taste, and so that's that lemon, that sour taste of the lemon. They're also corrosive, whether that's a mild acid or a more dangerous one. They're all corrosive to some degree. They are capable of breaking down or eating away other materials, such as living tissue, cloth, even metal, if they're strong enough. And many acids are also poisonous. And so there's some that are safe, obviously, and then there's some that you do not want to swallow. So some common weak acids include citric acid, found in citrus fruits like oranges or lemons. There's also acidic acid, which is found in vinegar. In fact, when we did a lab a while back, one of the um, independent variables that you were using was acidic acid. That was just vinegar, as many of you found out when you opened it and smelled it. Then there's carbonic acid, which is found in soft drinks. And so that favorite soft drink you have, Coke, Mountain Dew, whatever it is, does contain acid in it. Stronger, dangerous acids that you would not want to eat include sulfuric acid and nitric acid. Both of these are used in both explosives and fertilizers. And so they're not things that you want to consume and put into your body. Um, Acids can also occur in our bodies naturally. You have stomach acid. Hydrochloric acid is present in your stomach to help digest and break down food. In fact, if you don't have enough hydrochloric acid in your body, you can't get the nutrients that you need when you eat. And so that's all the notes there that you have for acids. And we're going to move on and start looking at bases. Base is a compound that releases hydroxide ions into a solution. And so you want to make sure in your notes that you get the difference between an acid and a base. Bases release hydroxide ions into a solution. They share some common properties and characteristics as well. And so bases have a bitter taste and a slippery feel. And so if you were to take a bite of that baking soda, it would have a bitter taste and it would have a slippery feel, especially once it gets wet. It starts feeling a bit slippery. Soap would be a good example of this as well. Like acids, they can also be corrosive and dangerous. So if they're strong enough, they're going to be harmful to us. But if they're mild enough, hopefully you use it whenever you take a shower. Things like soap. Some common bases include aluminum hydroxide. It's found in antacids. And so when you have that heartburn and take the Tums, that aluminum hydroxide is helping to calm down the stomach acid that's giving you the reflux. Calcium carbonate used in chalk. Now we don't have chalk in our class. Excuse me, we don't have chalk in our class because we have whiteboards and smart boards, but I'm sure you probably were in a school at some point that had some chalk, and that's calcium carbonate. Sodium hydroxide, which is found in soap, drain cleaners, and other cleaning products. And so all those things are basic, and most of them we use on a fairly regular basis. Moving on now, as we look at acids and we've looked at bases, let's look at what happens when you combine an acid and a base. And that's going to be a salt. And so we've talked about some salt already in table salt. and that being a compound when two things come together. But let's look at the idea of a salt in terms of acids and bases. When an acid and a base react with each other, they can form a salt. The salts form when negative ions from the acid combine with positive ions from the base. So you see that bond that's happening, the chemical bond, the chemical reaction that's happening, and the salt is formed out of that. Salts are neither acidic or basic. They both are neutralized. And so what this means is they don't have the same characteristics or properties as the acid or the base. Um, they have a lot of uses. We use them in our homes. We use them in industry. We've talked about one, table salt we use to preserve food, season food, make it taste better. Some other uses that we have for salts, we de-ice roads with it, make paint with it, fertilizers, glass, dry cell batteries, wall boards, and even film are all made using salts. So we base acids, we've talked about bases, we've talked about salts. How do we tell the difference between an acid and a base? If we don't want to taste it to know, does it have a sour or bitter taste? Maybe we don't want to feel it to see if it's slippery because it could be corrosive and damaging to our skin. So how will we know if something's an acid or a base? We'll use what's called indicators. To determine if a substance is an acid or a base, an indicator is used. Now, indicator is a compound such as litmus paper. We'll use some of that probably this week. It changes color to identify bases and acids. If you have a red litmus paper, you put it in an acid, it's going to stay the same color. But if you put it in a base, it'll turn blue. If you have blue litmus paper and you put it in a base, it stays the same. But if you put it in an acid, it turns red. And so you can see that there, that litmus paper turns red when placed in an acid, blue when placed in a base. We also have pH paper, or digital pH meters. pH paper is going to be usually like a yellow color, and then when you put it into a acid, it turns red, and when you turn it into a base, it turns blue. The pH scale is what's used to measure how acidic or basic a solution is. And so the pH scale ranges from 0 to 14, and it's used to measure the hydrogen ion concentrate in a solution. And so that means it's measuring really how acidic it is, but it also that tells us how basic it is too if it doesn't have those hydrogen ions. And so it'll be a color scale that you use, different shades of each color, and gives you an idea of what that solution is. Solutions with lower than 7 are acidic, and so those, if it's 1 through 6, you're going to have an acidic solution. Greater than 7, basic. So 8 through 14 is going to be basic. The closer it is to 7, the weaker it is. And so if you have an acid that's a 6 and a base that's an 8, those are both going to be weak, and because they're both close to neutral, which is 7. So a pH of 7 is a neutral solution. A neutral solution, the most common one, is water. Water should be neutral. It should be a basic 7 unless something else is in there causing it to be acidic or basic. It's why also we use 7 to clean our eyes. If we got something in our eyes during a lab, to wash our hands with, if we get something on our hand, because it neutralizes that acid or that base. It waters it down so much to the point where it can become more neutral and becomes safe. From here, you're going to go on and read a couple of articles, answer some questions. If you did not get something in one of your fill in the blanks on these notes, you need to back this video up and get those notes from this PowerPoint. And so go ahead, and if you've gotten all your notes, move on to the next part of the assignment, and we'll continue to learn about acids and bases.